Good morning, everybody. How you doing today? Today we are going to continue with logs, and it would help if I unfroze the screen. Today we're going to continue with logs, and today we're actually going to be really learning, introducing logs. Logs are the inverse of exponentials. Okay, if you remember, the exponential parent is y equals bx. Or you can have y equals abx, and something in front of it. And of course, you can have shifts from there. So remember what we talked about, guys? We talked about when we have an inverse, you're replacing the x with the y, correct? You're replacing the x with the y. Well, when you have the inverse of an exponential function, you get a special kind of function called a logarithmic function, okay? I don't want you guys to stress about logs because they're not that bad at all. You have to think of a logarithm as being basically a different way of writing an exponent. That's all a log is. A log is just taking an exponential value, an exponent, and inverting it. And you're rewriting it in a new way. And the basic parent of log is y equals log base b of x if and only if b to the y power equals x, where b is not 1 and it has to be greater than 0, so it's not negative. Let's investigate this little formula. Log of b, okay, this base b here, that's the base. If you think about it, remember when we were talking about exponents, for example, x to the third power. Remember that x is the base, right? Well, that's what we're talking about. When you are writing the log, which is the inverse of an exponent, that little number down there, that b, that stands for the base. And that base means the base of the actual exponent value. You guys with me? Okay. Then we have the answer, okay? X, this time, is the answer. Remember, we are inverting this. Okay, sorry about that. So remember, X is the answer here. It's not the independent variable. Remember that I just said that the log is the inverse of the exponential. So if we invert it now here, this time, the x is the actual answer, okay? And then y is the exponent. So y would be this 3 when you set it up, if you were going to go ahead and set it up as an exponential value. So b is the base of the exponent, or exponential expression. Y is the actual exponent, and x is the actual answer, okay? I want you to understand this. Now, trust me, we're going to have a bunch of practice on this today. I promise you guys. Let's just first get some more facts, okay? When you have this log base b of x equals y, this is read officially as log base b of x. I understand what it's saying. It's saying the log of base b times this x equals y. Yes, it is. I don't like to teach it that way, though. The way I read it, is log of base b to the y power equals x. That's what I like. Because what happens here with the log here, guys, you're taking this base b, you're raising it to the y power, and it's giving you the answer x. That's what's happening here. If you look, that's what's happening here. Okay? So the y is now independent, the x is now dependent. So, yes, this is officially read as log base b of x. Yes. I like to read it as log base b raised to the y power equals x. It's more complete for me. Okay? And I thought that it would be a little bit easier and it would make more sense for you guys. Now, this is not in your book, but I'm going to go ahead and expand upon it because I have to. It's the right thing to do. There are two main types of log. The reason why I say main types of log is your calculator has a log key, and your calculator has an ln key. Those are two very, very specific logarithms. You cannot, I repeat, you cannot use those logs on your calculator to solve everything. In fact, you're very limited with those two log buttons. Okay? Common log is log of base 10 of x. It's log base 10 of x. Or you can just write log of x. Hence, why when you see this symbol here on your calculator, that works fine as long as the base of your log is 10. That is called common log. You also have natural log, which we already saw this, right? Remember we talked about E when we were talking about the PERT? Remember PERT, guys? The continuous compound interest? E, if you remember, is Euler's number. It has an exact value, and it's Euler's number. When you have Euler's number, E, as the base of a log, you can write it as log base E of x or ln of x. That's why there's an ln key on your calculator as well. All right? So if you just see the log key, you can solve that as long as your base is 10. If you have an ln, you know it's a log of base E, you can use the ln key because it's a base of E. Other than that, you're out of luck. That's why we're going to learn how to do stuff without a calculator today. Exponential functions, remember, and logarithmic functions are inverse functions. We've already said that a couple times, but I want to show you how powerful that is for logs. Okay? Since y equals b to the x power, okay, this is an exponential, right? And log of base b raised to the y power equals x, that's a log function. Since they are inverses, if I have, guys, base b raised to the log of base b of a value a, this base and this exponent can cancel and you will be left with a. So if I have base b raised to the log of base b, since they are inverses, these guys will cancel and my a will be the answer. On the flip side of that, if I have a log of base b of b to the a power, same thing. Log base b of b, those b's cancel, and I'll have a left over. So if I have b raised to the log of base b, those cancel, and my answer is what's left over. If I have log base b of b, those two cancel, and I have what's left over. Okay? You guys with me so far? We're going to do a lot of examples, I promise. Bear with me, guys. I know it's a lot of stuff right now. Just bear with me. And then again, yes, sir. In front of, no, it's log, L-O-G. It's not a 1. Thank you, sir. Thank you. He was asking if this is a 1. No, it's log L. Thank you, son. And again, I know I already repeated this, but please note that the log key on your calculator is only for common logs of base 10, and the ln key is only for base E. Okay, please remember that. Now, let's get to work. Okay? Don't fear this. I know it looks crazy, but don't fear it. First thing I want to show you guys is how to rewrite equations into exponential form. Let's make sure that this is real. Remember how Mr. Morrow reads this. This is log of base B6 to the y power, which is 2, equals the x value, which is 36. And that works. Do you guys see how I did that? Base B to the y power equals 36. Base B to the y power equals 36. Does that make sense, guys? Are you sure? Okay, check this out. Base of 289 to the 1/2 power equals 17. And that does work, because what does the 1/2 power mean, guys? Square root, thank you. The square root of 289 does equal 17. Everything is kosher. But how do you write this as an exponential again? Base B to the y power equals x. Done. Number 3, base 14 to the negative 2 power equals 1 over 96. 1 over 196, sorry. Not 1 over 96, 1 over 196, sorry. Base B to the y power equals x. What would number 4 look like, boys? Awesome. Base B raised to the 4th power equals 81. And of course, all of these work. Sir. Log is okay. Log is not an actual value. It's a function. It's not a value. It's a function. Well, the log is gonna. Well, remember, since log is inverse of exponential, what happens is it's gonna have the inverse graph. But I don't understand what you're saying, though.
If I were to take the log out of the equation.
Oh, if you were to take log out of this equation, yeah, it completely messes everything up, because log is a function that's amplifying that equation in a certain manner. If you take away log, then you have nothing. You don't have log anymore. You just have a regular set of numbers. Okay, sir? Thank you, sir. Now, guys, let's go backwards. Okay? Let's rewrite each equation in logarithmic form. Remember, just hear me out, guys. This is what Mr. Morrow does. I didn't like this a lot when I was a kid. I was very scared of it. So I'm going to try to give you all the tricks that I know. I will label. That's the base. That's the exponent. And that's my answer. So, log base B, answer, exponent. And if you guys, look at it, it does make sense, because the square root of 64 equals 8. Does that make sense, guys? Okay. Number 6, log of base, which is 12, of the answer equals the exponent. Please, guys, if you don't see this, please talk to me. This is the easiest part, but if you really understand this, the rest it continues to be very easy. But you need to know today's lesson really, really well. What would number 7 look like, gentlemen, as a logarithm? Log base 9, good, of the answer, 1 over 81, equals negative 2. And yes, 9 to the negative 2 is going to be 1 over 9 squared, which is 1 over 81. Awesome. Number 8, what do we have here? Log of base of 112, don't let it scare you, of the answer, 144, equals the exponent of 2. Absolutely. And if you can see that, of course that makes sense. 112 times 112 is 144. Does that make sense, boys? Okay. You don't have to solve these. We're just rewriting them. Don't get scared of these. Rewrite each expression each equation in exponential form. Okay, what's my base? Base of u to the v power equals 15/16. Done. 10. What do I got? Base v to the 4th power is u. Excellent. Excellent. Next. Excellent, boys. 7/4 to the y power equals x. Awesome. Next. 2 to the u equals v. Heck yeah. Next. U to the negative, what is that? What am I writing there? Okay. U to the negative 16th equals v. Yes. Next. Y to the negative 8, which is equals x. Not bad, right? I bet you thought this was going to be a lot harder when you saw these, right? No? Okay, some of you thought it was easy. Cool. Okay. Rewrite each equation as a logarithm. What do we got here? Log base u of the answer v equals negative 14. Awesome. Next, 16. Log base 8 of the answer equals the exponent b. Next. Log base 1/5 of answer y equals exponent x. Next, log base 6 of answer, of answer equals exponent y. Are you with me, guys, here, or am I going too fast? Okay, next, 19. Log base 9 of answer equals exponent y. Next, 20. Log base b of answer equals exponent a. Good job, bud. Good job. Good job. Okay, now comes the fun part. Now let's put all of this into action. Now your multiplication skills are going to have to be tested here. You are not, I repeat, not, it's not that you're not allowed, let me rephrase this, that you are unable to do this without a calculator right now. There's going to be a way to do it with a calculator, but I'm not going to let you do it yet, okay? I will tell you this, though. I was looking at everything that's coming up, and it breaks my heart, but you're going to have to get a calculator for this class. I suggest you go to Office Depot or anywhere and get the I think it's the TI X30. It's not a graphing calculator. Do not get a graphing calculator right now. This is only like $12. It's solar powered, and it has everything that we need, and the best part, I know how to work with it very well. If you get a calculator that is different than that, I may be able to help you, I may not, okay? But get the one that's solar powered, yes. If you have your own calculators already, then that is fine. If you don't have a calculator, then get one. Yes. I'm sorry? Do I have that on me right now? No, but I'll bring it tomorrow. Yes. Like I just said, if you have a calculator, that's fine. If you do not have one, I suggest you get the solar-powered TI X30, I believe is what it's called. I'll bring it tomorrow, okay? Now, For these, though, we will not need a calculator. We're going to evaluate these. Guys, doesn't log base 4 of 64 equal some exponent that made that 4 turn into a 64? Well, that's what we're going to do here, guys. We're going to be rewriting these, bless you, as exponentials, and then we're going to see what power do I need to put in there. Unfortunately, you are going to have to think about this. Yes, sir. Y is 3. Yes, very good. 4 to what power equals 64? Y in this case is 3. Absolutely, sir. 6 to what power equals 216? Remember, there's a Y here that you don't know about. To the what? Is it to the 4th? To the 3rd. Y equals 3 as well. Okay? Next, 4 to what power equals 16? Y equals 2, not 3. This is a great one, guys. 3 to what power equals 1 over 243? First of all, it has to be a negative. Thank you, son, because you know you're reciprocating it. You bring it to the denominator. Phenomenal, first of all. Because on an SAT, 3 of the answers are going to be positive, and you can get rid of those immediately. Good. Now, to what power? Just do the math. Yes, to the negative. Very good, son. Y to the negative 5th. Okay? Well, think about it. 3 times 27, right, is going to be 81. And 27 is already 3 cubed, so that's 3 to the 4th. 1 more 3, and that's it. 3 times 81 is 243. 5 to what power equals 125? 5 to the 3rd power. Yes, not 5. There's 3. Relax, relax, guys. Relax. And then 2 to the blank to what power equals 4? Remember, 2 to the squared. Exactly. Guys, believe it or not, there are juniors in this world that haven't learned this yet. You should be proud of yourself. I'm proud of you. Let's continue. Okay. 343 to what power equals 7? To the 1/3 power. Wait, is it? No, not 1/3. Wait. Let's do the math. 7 times 7 is what? 49, right? And what's 49 times 7? Yeah, you're right. So this is going to be y will equal the 1/3 power. Now, for those of you that are like, wait, what just happened here? Think about it, guys. Remember that when I have x to the n over m, that's the m root of x to the n power. So I had this 343, and the answer is 7. Now, I know I didn't apply a negative exponent to it because it would have been a fraction. So I had to apply a fractional exponent. I had to put this in some sort of a radical. And the 3rd root of 343 equals 7, as we proved a few seconds ago. So, yes, y will equal 1/3, which represents the cube root. Does that make sense, gentlemen? Okay, thank you. Okay, 2 to what power equals 16, bro? Y equals 4. Heck yeah. Remember, there's a y there. They wanted you to evaluate it. 64 to what power equals 4? 1/3 again. Yes, y equals 1/3. Think about it, guys. The cube root of 64 equals 4. Okay? 6 to what power equals 1 over 216? Now remember, it's a fraction, so you know it's going to be a negative for sure. Awesome. And then it's going to be y to the net equals -3. Because 6 to the -3rd equals 1 over 6 cubed, which is 1 over 216. Gentlemen. Does that make sense, guys? All right. And then the last thing that I wanted to show you guys was the last thing I had explained to you, the whole inverse property. Okay? That whole inverse thing is really powerful. 12 to the log of 12, guys, don't stress your life. Cancels, it equals 144, and that's it, period. Period. That is the answer. That is this expression simplified. Look at 32. 5 to the exponent of log base 5, that's going to equal 17 right off the bat. That value is 17 because in this first one, gentlemen, again, the base 12 and the log of base 12, they're inverses. So I'm left with my A, which is 144. Here, base 5 to the log of base 5, they cancel. I'm left with my A, which in this case is 17. X to the log of base X. Have a good day equals 72. Done. 9 raised to the log of base 3. Oh. Okay. It's not going to be 60, and that's a great question. Check out what happens here. Doesn't 9, guys, really, isn't that 3 squared? So what's 3 squared? Log of base 3 times 20. This base of 3 and this log of 3 cancel, correct? So what am I left with? 2 times 20, which is, wow, epic fail, 40. Does that make sense? Don't always just look for it to be exact. Sometimes you have to transform them a little bit. Does that make sense, guys? Do you guys want to practice this, or do you want to continue to the next lesson? Okay, show of hands real quick. Democracy. Okay, we're going to practice. Thank you for this great lesson, guys. God bless you. We'll practice right now. Okay, that was really silly of me. Psych, we're not practicing. We just had 34 questions of practice. Ha ha, I'm joking. Sorry, guys. We got a graph. Ha ha. All right, but look. Hey, be honest. Was exponential graphing tough? Yes? Yes? You guys are saying yes, exponent? No, okay, you're being sarcastic. All right. I promise you, graphing logs, same thing. It's not that difficult at all. Just like all functions, guys, logarithms can be reflected, stretched, compressed, shifted to the left or the right, and shifted up or down. So let's see how it works for logs. And I don't know why I put exponential here. Scratch those out on your papers. Scratch them out. Okay. Logarithm parent function is y equals log base b of x, where b is not greater than or equal to, sorry, I made a few typos apparently, but where b is greater than 0 and b is not equal to 1. The complete logarithmic function is y equals a log base b x minus h plus k, where, just like before, a is either the stretch, the compression, and or reflection. If the absolute value of a is greater than 1, you have a stretch. If the absolute value of a is a fraction, it's between 0 and 1, you have a compression. And if a is less than 0, there is a reflection in the x-axis. B is my base. Now, I don't know if you guys remember, but in an exponential, wasn't my k the asymptote? Right? Well, this time, the h The h shifts the graph left or right for sure, but it also determines this time the vertical asymptote. If you remember, an exponential had a horizontal asymptote, right? You with me, guys? Remember, we're talking about inverses now. So a logarithm will have a vertical asymptote. You feel me? Again, why, Moro? Why? They're inverses. They're inverses. The x's switch places with the y's. So the h is going to determine your asymptote. And of course, the k shifts the graph up or down. I was looking at the different procedures. I was testing it last night. And I'm going to go just like with what we did on the exponential. Let me show you what I mean. Or just like with all of them. Let's say I have y equals log 3 of x plus 1. You have a little bit of a pickle here, guys. You got a little bit of a pickle here. You cannot use your calculator to find these values. So you know what, guys? Simply turn it into an exponential. So the first thing you're going to do is you're going to say 3 to the y power equals x plus 1. That's the first thing we're going to do. So the first step here, always, in graphing a logarithmic equation, my friends, or function rather, is to convert it into an exponential first. You with me? Okay. Second, make a table just like before. However, this time, who's my independent variable? No. Remember, guys, look at it. Y is the exponent here, so y is the independent variable here. So you're going to choose values for y and solve for x this time. So, let's just go ahead and do it. Let's go -2, -1, 0, 1, and 2. When x is -2, you've got 1/9, but you subtract the 1. So to find x, so -1 and 1/9. You guys with me there? Hello? Okay. When x is -1, you got 1/3. You subtract 1, though. Whoa, this is wrong. This is wrong. It's 1/9 minus 1. Hello? So that goes. So this is -8/9. Sorry, guys. Then you have, when x is -1, you got 1/3. 1 minus 1/3. Or actually, -1/3, positive 1/3 minus 1, you're going to have -2/3. When y is 0, that's 1. 1 minus 1 is 0. When y is 1, 3 to the first power is 3, minus 1 is 2. And when y is 2, that's 9 minus 1 is 8. In this case, do I have an asymptote? Do I have a vertical asymptote? Yes, I do, because I have an h. It's 1. Remember, guys, that's my h plus k, which in this case, k is 0. You guys with me here? Huh? Yeah, but it's the 1. Yeah, it's going to be -1, but yeah, that's my h. Remember, they're always opposite. Yeah, I'd have to. So this graph is going to be shifted, right? So my asymptote is right here. I cannot cross that. Okay? So at -1, actually, I cannot use that value. I cannot use that value at -1 because that's my asymptote. Okay? What do you mean -2? Oh, yeah, I cannot use -2 either, actually. Yeah, I can't use -2. So I have 0, 0. Oh, yeah, hello. See, I got confused there for a second. My bad. Yeah, I cannot use x is -1. Doo-doo-doo. Okay. But no, I can't cross over, though, either. I have 0, 0. I have 2, 1. I have 8, 2. And then when x is -2, see, I can't have that. Yeah, that's right. When y is negative 2. Hello, stupid. So yeah, so x is negative 8/9. So here's negative 2. 2/3. It's about here. There we go. So that's my graph. I'm not going to kill you with these, but I need you to know how to work with them because, as you saw, I got confused because I'm so used to, we're all so used to xy, we have to reverse that. So I apologize for that confusion. Yes, sir. Yeah, we could do 3 points if you want, bro. That's fine. Okay. I'll be fair. I'll be fair, son. I'll be fair. Let's do this one in red, boys. Okay, first things first. There's no way you're going to be able to solve for this by making a table unless, excuse me, you go by exponential. So you go 3 to the y power equals 4x. Literally. Literally. And you make a table. And you're going to choose values of y. So like you had asked me, let's do negative 1, 0, and 1. That's fine. I accept that. So 3 to the negative 1, that's 1/3 divided by 4. That's 1/12. 0, you got 1 divided by 4, 1/4. 1, 3, 3/4. So may I erase this blue one? Okay. Do we have an asymptote here in this case? It's 0. Whenever there is none, it's 0. So my y-axis is the asymptote here, gentlemen. And I've got 1/12 negative 1. That's real close here. I got 1/4 0. That's like, right here. I'm estimating, of course. 3/4 1. That's like about here. So it's going to, see, you may need another point here, guys, because I don't really know where it's cutting, where the angle is. So let's just do 2 here for giggles. 9, so that's 9/4. So 9/4 is 2 1/4. So 2 1/4, and y is 2 here. So okay, there we go. So it's roughly like that. Does that make sense, guys? For giggles, what's the domain? Right, we have from 0 in parentheses because it's not equal to positive infinity. And what's my range, boys? Very good. Negative infinity to positive infinity. Very good. All real numbers. Remember, domains express the possible x's. Range expresses the possible y's. Yes, sir. You could have put the all real number sign. Yes, sir. It depends. Sometimes they ask you to put it in interval notation. So it's always good to know that, sir. Thank you, bro. Does that make sense, my brothers? Now we are done. Thank you for an incredible lesson, guys. You were awesome today. Thank you. What am I doing? What am I doing?